as I was saying, so this alternate method of multiplying will be useful for us when we get the factoring. Now, one thing we want to do whenever we're factoring is the first thing we always want to look for in a polynomial is greatest common factor. So basically a distributive property backwards. So x squared minus 3x, what is the greatest common factor between x and the 3x? X squared and 3x is an x.
Gosh, every single time, Mr. Dorn.
That worked out well though.
It did.
Okay. That didn't. Okay. We take out the x and we left with an x minus 3. So to kind of do distributive property backwards. What is the greatest common divisor for these two? 2x cubed minus 6x squared, well that's going to be a 2x squared. Goes into both of those. Leave me an x. And negative 6x squared divided by 2x squared just leaves me minus 3. So the first thing we look for when we do any factoring problems is we always look for greatest common factor because we get smaller numbers when we're done and that makes our factoring easier. So that's just kind of a little reminder. The polynomial AC method for factoring is something you may not have seen before. But it is an effective way of factoring a quadratic trinomial that has a number in front of the x squared. Again, it goes back to the idea of finding magic numbers, the way we talked about yesterday. But instead of the product just being the c, the product is now a times c, whatever that is. We have to multiply those two values, which actually we were doing yesterday. It's just that there was always a 1 in front of the x squared. So we were doing this. What it does is it kind of complicates the process now because my magic numbers are no longer my factors because I no longer have a 1 in front. But they do tell me how to find my factors consistently and quickly. So we use that to split up my middle term. And I'll show you how that works. Say, for example, I have 3x squared minus 10x plus 8. And I need to factor that polynomial. Well, my a here is 3, and my c here is my positive 8. So AC is 3 times 8, or 24. So I need two numbers that multiply to give me a 24. I'm looking for my magic numbers. And add to give me the negative 10. So it should be negative 6 and negative 4. This is a negative 10. So my magic numbers in this case are negative 6 and negative 4. But my polynomial isn't x minus 6, x minus 4. Because, number one, that wouldn't work. Because x times x is not 3x squared. It's just x squared. So what we do is we use those magic numbers to split up my middle term. I'm going to split that into two terms. And I know, and the exact way we split it are by my magic numbers. So that negative 10x gets split into a negative 6x and a negative 4x. Which is the same as negative 10x, we're just going to split it up. My 3x squared stays, and my plus 8 stays. So my polynomial is now 3x squared minus 6x minus 4x plus 8. We then regroup my polynomial. I group the first two terms, and I group the last two terms. Now, I group after a negative sign, which means I have to factor a negative out of this, which means I have to change this positive 8 to a negative 8. Yeah, that's kind of a tricky one. But notice, now I look for greatest common factor. What's my greatest common factor between 3x squared and 6x? 2. 2 doesn't go into 3. Okay. 3x, right? 3x comes out of both those, leave me an x minus 2. Greatest common factor here is a 4, leave me an x minus 2. Which now we have greatest factors of x minus 2 And if I factor those out, I'm left with a 3x minus 4, which is the complete factoring of that polynomial. Now, it's kind of a process. It's kind of a process to do that. But the advantage of the AC method is that our only guess and checking is done when we're looking for that product sum, which is something we're used to doing. And then we can, as long as we follow the algorithm, it gives us our factors every time. So that's the beauty of it. It's very minimal guess and check. An alternative method is the box method. The box method, what we do is we say, okay, I've got 8x squared and negative 15 is negative 14x. So I've got 8x squared here and a negative 15 over here. This is the product of my first numbers, this is the product of my last numbers. Somehow these two boxes are going to have to add up to negative 14x. And we got to figure out how that's going to happen. So we kind of have to guess and check a little bit. Well, what's going to give me 8x squared? How can I get to 8x squared? Well, maybe it's 2x and 4x, maybe it's 1x and 8x. I don't know.
Negative 15 times 1.
Okay, well, wait. That's for the negative 15. We're about to say 8x right now. 8x squared. So let's guess that it's 2x and 4x. Okay? We're guessing. We're literally guessing at this point. Okay? Now, what two numbers give me a negative 15? You said negative 15 and 1. Now, how do I know which one gets a negative 15 and which one gets a 1? I don't know. I'm going to guess. So I'm going to guess negative 15 and positive 1. Well, let's see what happens with these two boxes. 2x times 1 is plus 2x. 4x times negative 15 is negative 60x. That doesn't add up to negative 14x, so that's not the correct combination.
This is like Zeno.
Okay? So try again. What else multiplies to give me negative 15? Negative 5 and positive 3. So let's try a negative 5 here and a positive 3 here. 4 times negative 5 is negative 20x. This is a plus 6x. Hey, that adds up to negative 14. So my factors are 2x minus 5 and 4x plus 3. I factored that polynomial. It's a little guess and checky. It can take some time. It can go through several iterations, okay? Maybe if this hadn't worked out, what if I had put the plus 3 over here and the minus 5 down here? We might have switched those two. That would give me a different middle total. Just because the minus 5 plus 3 didn't work this way doesn't mean it wouldn't work the other way. So it's a little less complicated in that we don't have all this factoring and grouping and pulling it apart that the AC method uses. It's very visual because it's right out in front of us with that box. But we might have to go through several different tries before we hit the right combination. And if I might not hit the right, it's possible that my 2x and 4x are wrong. This could have been an 8x and a 1x. So there could be a lot of tries before you find the right combination. So you have to be patient if you're going to use this method. So 2 different ways of factoring a quadratic trinomial with leading coefficient other than 1. So let's say I have 10x squared plus 3x minus 4. Which way do you want to try? The box way or you want to try the AC way?
AC way.
Okay, let's try AC. So we're going to do the AC method. AC is negative 40. B is positive 3. I need 2 numbers multiplied that give me negative 40 and add to give me 3. Well, some people kind of struggle with this a little bit, so let's think about this a second. Could be 40 and negative 1. No. 20 times negative 2 to give me negative 40. No. 10 times negative 4. No. 8 times negative 5. There it is. There's my combination. Some people go to it right away. Some people need to start making a list of factors. Whatever works for you. So 8 times negative 5, so magic numbers are 8 and negative 5. Now, if I have a positive and negative, I'm always going to put the negative one first. So I'm going to rewrite this as 10x squared minus 5x plus 8x minus 4. So if I have a positive and negative, the negative is always going to go first because it just makes life easier. I'm now going to group the first two and the last two. I grouped after a plus sign, so I don't have to make any changes. Greatest common factor is what for here? 10x squared minus 5x. This is my greatest common factor. 5, not just 5, but 5x. The first pair is always going to have an x as the greatest part of the greatest common factor, okay? If I take out a 5x, that leaves me 2x minus, now 5x divided by 5x is 1. Plus, greatest common factor between 8x and minus 4? 4. Leaving me a 2x minus 1. Now, with this method, if these two don't match up exactly, I've made a mistake. Because this method guarantees that those two must match up, if you're doing it correctly. So then the next common factor I have here, again, is a 2x minus 1. Factor that out, leaves me a 5x plus 4. And we are factored. Oh, thought I had more examples. Let's do another one. 5x squared. Let's try this. Plus 6x minus 8. Let's do this one using our box method. So I got a 5x squared here, and I got a minus 8 down here. Now, I've only got really one combination that gives me 5x squared. It's going to be an x and a 5x, right? So that's kind of nice. There's no other combinations to get the 5x squared. Now with whole numbers, you know, so I have the whole numbers. So you have an x, and we have a 5x. Getting negative 8, I've got a lot of choices. That could be it could be 1 and negative 8. It could be negative 8 and 1. It could be negative 4 and 2. It could be 2 and negative 4. I mean, we got a lot of combinations to get to negative 8. So we got to kind of pick one that we think might be a good candidate. What combination do you want to try to get to negative 8? Start with. Give me a guess. Negative 4 and positive 2 would have to be, right?
Oh.
So let's make this one the negative 4 and this one the positive 2. Let's see how we did. 5x times negative 4 is negative 20x. X times positive 2 is plus 2x. That's not a plus 6x. So that one didn't work out for us. What if I switched them? What if I did the negative 4 here and the positive 2 here? 5 times 2 is, that's a 10x. X and negative 4x. Aha! There it is. We got it. It's x plus 2 times 5x minus 4. Two guesses. That's not so bad. Okay, one didn't work. I just switched where those numbers were. Try it again. We have to be willing to make multiple. If we're going to use this method, we have to be willing to make multiple guesses.
Oh my god. Oh, that makes sense.
Okay. Now, let's go back just a little bit and do what we're doing, because what we do is we don't just solve the polynomial, we do this. Now, the equals 0 doesn't change anything until we've factored first. And all the problems we're going to see today are going to be set equal to 0, but we're still going to have to start by factoring. That's really gross sounding. So we still factor at first, we set it equal to 0. But here's where my zero product property comes in. Now that I'm factored, in order to multiply these two numbers together to equal 0, it means either this equals 0 or that equals 0. So that means that 2x minus 1 equals 0. Whoops. Minus 1. Ahead of myself. Or 5x plus 4 equals 0. Then we have two little mini algebra problems to solve. Add 1 to each side. 2x equals 1, divide by 2. So x equals 1/2 is one solution. Subtract 4 from each side. Divide by 5. So x equals negative 4/5 is my other solution. So these are the two solutions for this equation set equal to 0. These are the two values I could put into that equation that would make it equal to 0. Now, they are ugly fractions. They're not pretty answers, and I would hate to have to put that in there and actually check them. But the only time we deal with the fraction is at the very, very end of the problem, so it's not a big deal. It's just my answer. Let's look at the other one that we did with the box method. Same thing, we factor it first, but then we set it equal to 0. So x plus 2 times 5x minus 4 equals 0 means that either x plus 2 equals 0 or 5x minus 4 equals 0. This one's easy, x equals negative 2. This one you have to add 4 to both sides. So 5x equals 4 and divide by 5. X equals 4 fifths. So x equals negative 2 or x equals positive 4 fifths are my two solutions. Now, for those who are interested here in why that works, what's really going on? We're setting that equal to 0. I'm just going to show you this for a second. 5x squared plus 6x minus 8. Okay? Okay, 5x squared. So y equals 5x squared. Where's my keypad? There it is. 5x squared minus, what was it? Plus 6x minus 8? Okay. Now this is the graph of that function. It's a parabola. We aren't going to worry about we aren't graphing. Don't worry. Okay. But what I want you to notice is where does this parabola cross the x-axis? Right there at negative 2, 0. And right there at 0.8 or 4 fifths, 0. That's where this graph crosses the x-axis. What were the solutions I came up with here? Negative 2 and 4 fifths.
Okay, go great.
Okay, so there is a direct relationship, and you'll deal with this a lot more in Algebra 2. But there's a direct relationship to when we factor the polynomial and get those roots, get those solutions to the equation, and the graph of the function. They have a specific meaning in the graph of that function. So there's a tie in here. Why do we factor? What's one reason we factor to find solutions? What do the solutions do? They tell me where that graph crosses the y-axis. Because remember, the graph is the pictorial representation of every solution to that function. Every point on this graph, if I pick a point right here, okay, Sorry, I had one. Get back there, okay? That set of ordered pairs right there, it keeps on doing that, but that's okay. That's popping up. If I put that x value in, I'll get that y value out. Every point on this graph, negative 1.91, whatever that was, negative 1, and I can't get it fast enough, it doesn't stay. But if I try the mouse this way. There, okay. See negative 1.923 and negative 1.048. If I put that negative 1.923 in for x, the y value I'm going to get out is negative 1.4048. Every point on a graph, the graph is simply a picture of all the solutions of the function. That's what graphs are. Not that we're going to worry about that in geometry. That's an algebra thing. But I always want you to understand that there is a direct connection between an equation and the graph, in that the graph is a picture of all the solutions of that equation. Every ordered pair that makes that equation true. That's what a graph is. And there are lots of applications to that. Lots and lots and lots. So, as we're factoring polynomials today and solving those polynomials, remember always that there is a connection between that and graphing. And so when you get into Algebra 2, or even if you're doing intermediate next year, if you can always kind of keep that thought in your mind, it's going to make things make a lot more sense. Because too many students, there's a total disconnect between the idea of the equation and the graph. They feel like two completely separate things, when really they are the same thing. They're just different ways of representing the same data. All right, let's do one more example, and then we'll turn you loose, at least for a little while. Let's take 15x squared plus 17x plus 4. Put my pen down again. So 15x squared plus 17x plus 4. Box or AC method? AC? Okay. Actually, I'll do it both ways, just so people see that. Okay. For AC, my AC value is 15 times 4, which is 60. And my B, my sum, is positive 17. So you have two numbers multiply that give me 60, but add to give me 17. 12 and 5, good. Okay? That was a good catch. A lot of people are going to go to 20 and 3 because 20 minus 3 is 17, but it's positive 60, not negative 60, so that 20 and 3 doesn't work. 12 and 5 are the magic number combination. Okay? So I'm going to rewrite this as 15x squared plus 12x plus 5x, because 12x and 5x give me the 17x, plus 4. We're then going to group it. Common factor here. I know it's going to be an x for the first one. What's the greatest, for the coefficients, what's the greatest common factor? A 3. Leaves me a 5x plus 4. What's my common factor here? 5x plus 4. What's the greatest common factor? Just a 1, right? There's no number that goes into both of them. So my greatest common factor is a 1. 5x plus 4. And now I have a 5x plus 4 is my greatest common factor. And 3x plus 1. If that set equal to 0, that means that 5x plus 4 equals 0. Or 3x plus 1 equals 0. So subtract 4. 5x equals negative 4 divided by 5. X equals negative 4/5. Here subtract 1. So 3x equals negative 1 divided by 3. X equals negative 1/3. So if I were to graph this, the places that would cross the y-axis are negative 1/3 and negative 4/5. Those are my solutions. It's a little bit cheap because we know what the correct answers are now for the box method, so we aren't guessing much. But if we were to do the box method, I'd have said, okay, I got a 15x squared here, and I got a 4 down here. And I'd have to guess, now we already know it's going to be a 5x and a 3x, so that helps us. And we'll pretend like we don't know, but 4, I've got 1 and 4 and 2 and 2. But I'm going to guess, what if I guess 2 and 2? Okay, well, this would be a 6x, and this would be a 10x, which would give me 16x, not 17x. Okay, so that wouldn't have worked. And we'd have had to guess again. Because the 6x and the 10x gave me 16x, not 17x. It needed to be a 17x. Oops. So what if we guessed then the 4 and 1? Well, 3x and 4 is 12x. 5x and 1 is 5x. Aha, there's my 12x, there's my 17x. So 5x plus 4 and 3x plus 1. You got
But
that
actually,
right.
it's way.
Well, that's why I'm showing you both ways. You can choose either way. The box method, like I say, you just might be doing a lot of guessing. But it works pretty nifty. All right, so that's it for today.